Hi, this is Mrs. LaBarbara. This is Regents Physics Chapter 2, Video 6. Today's topic is friction. The objectives for today are know the definition of friction, understand the factors affecting friction, the difference between kinetic and static friction, be able to interpret graphs of applied force versus time to determine maximum static friction and kinetic friction, be able to determine normal force and the friction. The friction force is the force exerted by a surface as an object moves across it or makes an effort to move across it. Its direction is opposite of its velocity when it is in motion. If it is not in motion when the object is being pushed or pulled, the direction of friction is opposite to the applied force. Friction is a result of two surfaces being pressed together closely, causing intermolecular attractive force between different surfaces. Friction force can be reduced by lubricant, such as oil. There are two types of frictions, kinetic and static. Kinetic friction results when an object moves across a surface. Its magnitude equals mu k times F normal. Its direction is opposite of motion, that means opposite of its velocity. F normal is a size of the normal force. Mu k is a ratio of friction and the normal force. It has no unit. It is called coefficient of kinetic friction between the two surfaces. We can go to the reference table to find its value. Coefficient of friction depends primarily upon the nature of the surfaces that are in contact with each other. It does not depend on the area of contact, the angle of the surface, or the temperature. Example, which box has more friction? Let's see. Friction equals mu k times F normal. So how do we compare mu k between these two, A and B? Mu k is the same because mu k does not depend on the contact surface. How about F normal? F normal is the same as well because F normal in this case equals to gravity. And it's the same box. The box have the same gravity. Friction is the same. Another example, which situation has more coefficient of friction? Again, coefficient of friction does not depend on the angle of the surface. Coefficient of friction only depends on the types of surface. Since in both situations the types of surfaces are the same, so coefficient of friction are the same. Static friction results when the surfaces of two objects are at rest relative to one another, and the force is exerted on one of the objects to set it into motion relative to the other object, such as either at rest or rolling. Here is a man pushing a cabinet, but the cabinet is not moving because the cabinet has a static friction. The static friction force balances the force that you exert on the box when the box remains at rest until it starts to move. So in this case, the static friction on the cabinet equals to the force applied by the man. Static friction can change. What does that mean? So suppose the man is pushing with 10 newtons of force and the cabinet is not moving. So obviously the man is going to increase his force to 50 newtons and the cabinet is still not moving. In this case, the static friction force has increased from 10 newtons to 50 newtons to balance his applied force. Now, if the man increases his force to 20 newtons, if the cabinet is still not moving, that means static friction force has increased to 20 newtons. It's going to keep increasing until that critical amount which the cabinet starts to move. So static friction is always less or equals to mu s times F normal. In this equation, mu s is coefficient of static friction, and its direction is opposite of exerted force. Example, you are pushing a desk with 20 newtons force, but the desk is not moving. What is the friction force on the desk? Well, the static friction balances the force you exert when it is at rest. So the friction is 20 newtons. If you increase your force to 30 newtons, but the desk is still not moving, what is the friction force in this case? That will be 30 newtons to balance the force you apply. So the net force in both cases are 0. Here is comparison for coefficients of friction for mu k and mu s. As you can see from this chart, mu k is less than mu s, and also coefficient of friction looks like is less or equals to 1. So this means kinetic friction is less than static friction. You'll probably have your experience. It's much harder to start moving something. But once they start to move, it's easier to keep it moving. Example, compared to the force needed to start sliding a crate across a rough, level floor, the force needed to keep it sliding once it is moving, is it less, greater, or the same? We know kinetic friction is less than static friction, so the answer is less. Here is a graph of applied force versus time. So you may have a force sensor, you attach the force sensor to a block, and you start to pull the force sensor. And this is the graph recorded. As you can see, as time increases, the force you applied start to increase. So this force equals to static friction. So as you increase your applied force, static friction also increases until that critical amount. This amount is called a maximum static friction. Over here, this amount equals to mu s times F normal. Then the boxes start to move. Once they start to move, the force will decrease because you will not need as much as force as you started to keep the box moving at a constant velocity. This force over here to keep the box moving at a constant velocity, that is your kinetic friction. In both cases, your net force equals to 0. Let's take a look at this example. Determine normal force and kinetic friction. A 20 Newton wooden box is sliding across a wooden surface. So first of all, 20 Newton wooden box. What does 20 Newton tell you? It tells you the weight of the wooden box. You need to draw a free body diagram to describe the situation and determine the normal force on the box. Finally, determine the kinetic friction acting on the box. So let's take a look at a free body diagram. You have a surface, you have a box, and the force is acting on the box. So there is the weight here, or gravity going downward. There is normal force going upward to support the box. Suppose the box is moving to the right, then your friction would be going to the left. That's the three forces. It didn't say you'll have applied force. So let's see, from here, can we figure out the normal force? Yes, we can. How? Normal force equals to the weight. Why is that? That is because the box is not moving up or down. The weight is 20 newtons, therefore normal force is 20 newtons. How do we find kinetic friction? We have our equation. Kinetic friction equals mu k times Fn. Where do I find mu k? From the reference table. This is kinetic friction between wooden box and the wooden surface. Wood on wood is 0.3 times what's the normal force? 20 newtons over here. So you'll have 6 newtons. Another example. Determine the normal force and the static friction. So a 40 Newton copper box is placed on a flat steel table. 40 Newton is the weight of the copper box. Draw a free body diagram to describe the situation. So here is a free body diagram. Because you are applying it, determine the minimum force needed to make the box move. So this is applied force is the minimum force to make the box move. So there is weight or gravity, there's normal force, there's a friction force, and here is your applied force. So your applied force and the force of friction, static friction, constantly balancing each other until it starts to move. Here's the free body diagram. What is the normal force? Again, normal force equals to the weight. So in this case, it's 40 newtons. How do you determine the minimum force needed to make the box move? The applied force in this case equals to friction force, which equals to mu s times F normal. Where do you find mu s? It's static because it's to make the box is just start to move. You'll find mu s in the reference table. It's 0.53 times 40 equals 21.2 newtons. That's it for today. Thanks for watching. See you next time.